Hello, this screencast is going to walk us through item number 3.9 from the textbook on page 57. I figured this can serve as a good example that we can use for the other problems in the text. And we're going to walk through specifically what are called the measures of central tendency. Measures of central tendency are various statistics that give us a sense of where the values of a set from a sample or whatever we take, where they tend to land, hence central tendencies, where the center is of these numbers. So in this problem 3.9, the question said, to the question, during your lifetime, how often have you changed your permanent residence? A group of 18 college students replied as follows. And then these were the 18 values that were collected by those 18 college students. And our task was to find the mode, the median, and the mean of that set of data. So first, we're going to walk through finding the mode. First thing I like to do, if I have a set of data like this, and I can do this either by hand, or you can use Excel, is I want to put them in order from least to greatest. So in black here, these were the numbers as given in the book, but in purple here, I rewrote them in order from least to greatest. One very key point is to make sure that you account for every one of the values that are given and how many times that actually occurs. So for example, I started off with the number 0. There are 1, 2, 3 zeros in this set. So I need to make sure I account for all 3 of those zeros. So I went through and put them in least to greatest order. So I still have 18 values. The first thing I did after I did this is I recounted these, make sure I had all 18. I don't want to miss any of them. All right. And then the mode is the one that occurs most frequently. I think of MO as most often. That helps me remember what that is. So the number that occurred most often here was the number 3. 3 was the reply from 4 different students. So that would be my answer here. There were no other values that occurred that frequently. However, let's say, for example, this 1 here was a 2 instead. That would have given us 1, 2, 3, 4 2s as well. If you have more than one reply that occurs kind of like a tie, where they both occurred most often, then you list them both. So if this one was a 2, then my mode would have been 2 and 3 as the 2 modes. And that's okay. Now we're going to move on to median. The median is the middle value. I think of a median of a highway is in the middle. That helps me remember that. So this was also important to put these in least to greatest order. So when I take a look at these, there are 18 values. So personally, I chip in from outside in. I know I'm going to go check this one off and check this one off, and then work my way in. And I find that I end up here in the middle. And when you have an even number of data points, there is no one middle value. And think about that. If you had 3 people online, there would be 1 person in the middle. But if you had 4 people in line, there are 2 people tied for the middle. So here we have 18 people in line, or 18 responses in order. These 2 values were stuck here in the middle. There was no one middle value. Since both of these values are a 3, then my median is 3. But let's say, for example, the 2 and the 3 were the 2 middle values. If that were the case, then I find the average of those 2 numbers. I would add them up, divide by 2, and I would get a median of 2.5. And I bring that up 2 reasons. Number 1, there are times that that's going to happen, and you need to know what to do. Number 2, to realize it is okay to have a median of 2.5, and to realize, wait a minute, that 2.5 didn't even occur. It's okay to have a median that is not an actual value of the set of data. All right. And again, that would occur if you have an even number of data points, and there are 2 of them here that are tied for the middle that are not the same. But in this case here, we did have two of them that were tied for the same. So the median was 3. Now I'm going to move on to the mean. The mean is the statistical term for the average. We kind of usually use the word average in a layman's term when we're talking about the mean. But in reality, all three of these are different types of averages. So the word mean is a very specific average. In this case here, the mean is when I add up all my values and then I divide by how many of them I have. I have up here symbols in blue that I want to point out. And these are important because these are going to be used throughout the course. The lowercase n. Lowercase n is the sample size. In this case here, I had a sample of college students surveyed. There were 18 of them. So my sample size was 18. This next symbol, sigma x, this uppercase Greek symbol sigma, means the sum of, or it means to add them all up. So lowercase x is the symbol for each one of these different variables or values that were taken from the survey. So this would be x number 1, x number 2, x number 3, and so on. There are 18 x's in this case, and I'm going to add them all up. So I'm taking the sum of my x values. And when I add up these values, I get 59. Now, the mean is when I add them all up and divide by how many I have. So in this case here, I had 59 divided by 18. And that gave me a value on the calculator of 3.277777778. And I'm writing this all out to just talk through this part the one time here. We will not have to do this all year. The screen of the calculator can fit all of this. All right, two things are going on. First off, I want to point out that this 8 really probably is a 7, and then the value after this would have been a 7, but it just didn't fit in the screen. So what the screen actually does is round for that last digit. And just to review for some of us maybe a while, how we're going to round is this. When we round to a certain specific digit, we look to the digit to the right. So it would have been a 7 here and a 7 here. If I look to the digit to the right, if the value is 5 or greater, then I round this value up. So this was a 7. There was a 7 to the right of it. Because this is 5 or greater, I round this 7 up to an 8. That's what the calculator does to fit it all on the screen. What we're going to do is follow what's called a rule of thumb. It's not a law, but a rule of thumb in statistics is when you have to round, you round 2 decimal places more than, or more precisely than the values that are given to us. So since all the values in the original problem were whole numbers, I'm not going to round this to 3. I'm going to round it to 2 decimal places more accurate than 3. So I'm going to take a look at this original value from the calculator. I realize I'm going to go 2 decimal places to the right. And then from this value, I need to look to the right again. Since this is 5 or greater, then this 7 rounds up to an 8. That's how I round that. Now, the other part of this is this double squiggle equal sign. This is not an equal sign, it's an approximate sign. The mean of these values is not exactly equal to 3.28. So since we're reporting 3.28, technically we are reporting an approximation. So it would be a good habit to get used to using this double squiggle here for approximate. You may see that in certain reports as well. That's what that stands for. This is basically telling you that this is a rounded answer. The last thing I want to point out is this symbol, X with a bar on top. Instead of the book and/or some reports stating the word mean as far as in words, this X with a bar on top is the same thing. This is the symbol in statistics for the sample mean. So when I see X bar, I know, okay, that's a sample mean. And in this case, the sample mean for these values was 3.28.